Assalamu alaikum everyone, this is me, Mr. Assam Zidane, and today we are going to explain together laws of reflection and the image formed in the mirror. Before we get involved, we have to just give an introduction about the law of reflection. We have explained this before together, but quickly I'm going to give you a quick hint about this. So actually guys, we have two laws of reflection. So first, what is the meaning of reflection? So reflection means the bounce of the wave. So when the wave or when the light ray hit a surface, so it reflects back. Exactly like when the light hits a mirror, for example. So we can just imagine the light consists of rays. Okay, so these rays are parallel rays. So these rays are parallel rays. So we can just take one ray to represent the light wave here. As you can see here in this example, okay, so this is called incident wave or incident light ray. So this is incident, and when this one is just moving, and the light ray, of course we know this, it moves in straight lines. So this light this light ray just hit this surface at this point, okay, then it reflects. When it reflects within a ray called reflected ray. Okay, so in this situation, if I just at this point make this imaginary line, which is called normal, so this is called normal, and the normal is an imaginary line from the point of incident. So it's imaginary line from the point of incident, from this point, as you can see here, okay, which is perpendicular on the reflecting surface. So this is the reflecting surface, like a mirror. So at this point, so this is the normal, just make right angle with this reflecting surface. At this situation, you will find this angle, which is called theta 1, okay, or say theta incident. So this theta angle, which is called incident angle, equal the reflected angle. So in this situation, so theta incident equal theta reflected. So the incident angle equal the reflected angle. So what is the incident angle? Actually, incident angle is the angle between the normal and the incident ray. Reflected angle is the angle between the normal and reflected ray. So this angle. So if that angle is 30, for example, degree, so the reflected angle must equal 30 degree. So the incident angle equal the reflected angle in its value or in its magnitude. Also guys, the incident ray and the reflected ray and the normal. So incident ray, reflected ray, and the normal, okay, to the reflecting surface all lie in the same plane. Actually, we have two types of reflection. We have the first type of reflection is called regular reflection. Okay, and the second type is called diffuse reflection. So regular reflection, it depends on the reflecting surface. So if the reflecting surface, as you can see here, like this example, is smooth, shiny surface. So in this situation, this is a regular reflection. So as you can see here in this reflection, all the parallel rays just reflect parallel to each other. So as you can see here, these rays are, this is the incident ray, so this is incident, okay, are parallel. So all of these incident rays are parallel to each other. So the reflected rays are also parallel to each other. So this is reflected rays. So the reflected rays, which is so unique about the regular reflection, is that the reflected rays, okay, parallel to each other. And this is exactly what happens in mirror. So in mirrors, shiny surface, shiny metal surface, in calm water surface. So all of these types of reflection is called regular reflection. Why? Because the reflected rays, okay, are parallel to each other, and this happens when the surface is a smooth, shiny surface, exactly like a mirror. But in the diffuse reflection, so the situation is different. In diffuse reflection, okay, the surface is rough. So this is rough surface. And when I'm telling you it's rough, it doesn't mean when you touch it, you will find it rough. Maybe it's in macroscopic, okay, it will be rough in macroscopic scale. For example, the sheet of paper in front of you now, okay, if you have a sheet of paper, so maybe you think it's smooth, but it's not, okay, it's rough. In microscopic scale, it's, okay, it's a rough surface. So if the surface is rough, uneven, okay, so in this situation, the diffuse reflection takes place. So what is so unique about diffuse reflection? Okay, the parallel rays or the reflected rays are not parallel to each other. So about this diffuse reflection, reflected rays are not parallel. Are not parallel to each other, as you can see here. So this is reflected rays, reflected, okay. So all of these rays are not parallel. This is totally different from this situation. As you can see here, the reflected rays, all of them are parallel to each other. But here, just the reflected rays move in all directions, which means they are not parallel anymore, okay. So actually, this is what happens in regular reflection and in diffuse reflection. So depends on the surface. Regular reflection needs a smooth, shiny surface, okay. In diffuse reflection, it needs rough surface, okay, like a sheet of paper, like all the surface around us. First, in regular reflection, you can see your image inside. The reason for this, because in regular reflection, the parallel rays just, the reflected rays are parallel to each other. But in diffuse reflection, okay, you can't see yourself. So here in this one, can't see yourself. If you look, for example, in a sheet of paper, or if you look, for example, on the wall, okay, so you can see your image. But on a mirror, you can see your image. On shiny surface, you can see your image. On calm water surface, you can see your image. The reason for this, because the reflected rays are parallel to each other. And now we are going to discuss the characteristics and the properties of image formed in a plane mirror. Actually, plane mirror, it's called also flat mirror. So flat mirror flat mirror or plane mirror, both have the same meaning. So the flat mirror, like the mirror you use to comb your hair, okay, or the one which is already exists in the bathroom. So in this situation, okay, we need to know how the image is formed in a flat mirror and what are the properties of this image. So let's check this together. So as you can see here, okay, so if this is a candle, so this is the image. So when you put a candle in front of a mirror, so it looks like, okay, the candle now it looks like inside the mirror. So now we are just inside the mirror, so you have to just imagine this. So this is inside the mirror. So this image looks like it's inside the mirror. So this image has some properties. Okay, first, it's upright image. So it's erect, upright, it's not inverted. Okay, so it's upright image. Also, it's virtual image, is not a real image. So this one is virtual. Virtual here means it's not real image. Also, the image had the same size and the same height. So if you look to yourself on a mirror, you will find, okay, you still have the same size. Your image has the same size. Okay, also the distance between the object and the mirror exactly like or equal the distance between the image and the mirror. So both have the same distance. So if you are 5 meters away from the mirror, okay, so your image, which is inside now the mirror, it looks like 5 meters away from the mirror. Also, okay, when you raise your right hand on a mirror, you will find your image raise its left hand, which is called in this situation, okay, your image is literally reversed. So literally reversed, okay, so when you just raise your left hand, okay, your image raise his right hand. So now we need to know what are the properties, okay, of the image formed in a flat mirror. Number one, it's virtual. Virtual means it's not real image, and I'm gonna to explain this, what is the difference between real image and virtual image in more details. And it's upright, which is it's upright, is not inverted, the same size at the object, the same distance from the mirror at the object in front of the mirror, literally reversed. Literally reversed. So if you just stand in front of your friend, okay, facing him, against him, so in this situation you will find this. Your right hand, okay, it's his left hand, and this is exactly what happens in the mirror. We need to understand and differentiate between what is the difference between virtual image and real image. Actually, guys, real image, it's inverted image. So real image is inverted image. Inverted means upside down. Inverted means upside down image. Okay. Also in real image, okay, can be received on physical surface. So in this image, okay, can be received on physical surface, exactly like the projector. So the image of the projector, you can just receive it on a screen, on a wall. So this one can be projected, if it was real image, so can be projected, can be received on physical surface, so or on a screen. So this one can be received on physical physical surface or screen. Surface. But about virtual image, the situation is different. In virtual image, it's not real, okay, which means it's always upright. So when you find upright image, okay, erected, this means this image, it's virtual. Also about virtual image, cannot be received on a screen. So this one cannot be received on a screen. Okay, and this is very important. Okay, so now we have two main points to differentiate between virtual image and real image. First, the image is inverted. Second, okay, the image for real can be received on physical surface or on a screen, like exactly what happens in a projector. The image is formed inside the projector. Okay, about the virtual image, like the image formed in a flat mirror, so it's upright image and cannot be received on a screen. About concave mirror. Actually, in mirrors, we have two types of mirrors. So mirrors can be classified into flat or curved. Curved mirror. Some books name it as a spherical mirror, so both have the same name, which means also spherical because it's a part of a sphere. Okay, so you can just find this. As you can see here, it's curved mirror, and this one, it's called concave mirror. So this is now concave mirror. Concave mirror. So this concave mirror, this is the back of the mirror. Okay, and this is the reflected surface or the shiny surface. So this is the shiny surface. Okay, so the image is reflected inside this one. It looks like a spoon. Okay, the part inside the spoon. So this is called concave mirror. And I'd like to share this with you now. This how the image looks like. Hey guys. Okay, as you can see here in this example, okay, this is what I mean by a curved mirror. So the image is totally different from flat mirror, and you can recognize this by watching this video now with me. So let's see it. What happens? The image. So the first. Okay. So as you can see here, the image, it's big image. If when this guy just facing the mirror, so when he is just very close to the mirror, so the image, okay, it has a bigger image. So the image is greater than the real object. Okay, let's see this again. So see, the head is different. Okay, now there is no image. So at certain point there is no image. Okay, then the image is just inverted. So the image is just inverted. So it's upside down image. Okay, let's see what happens. Okay, now the image it just gets smaller and smaller and inverted. Okay, this is exactly the kind of a flat mirror, of a concave mirror. So now let's see together. So what is the concave mirror? Actually, concave mirror, it's the mirror, or it's a curved mirror which is reflecting surface, okay, inside of a spherical shell. So this is the inside, this is the reflecting surface, okay. Then we have this ray or this axis, Okay, so this axis, it's actually in the middle of the mirror, so it just divide the mirror into two halves. Okay, we have this half and that half. Okay, and this one is called optical axis. So optical axis. So optical axis actually, okay, it's the axis which divide the mirror into two equal parts. Okay, so this is called optical axis, and in some books is called the principal axis. Principal axis. So it's called optical axis or principal axis. This point, okay, as you can see here, this mirror, it's a part of a sphere. If we just continue this one, or you just complete this sphere or this curvature, okay, so what happens? Now it gives you a sphere. So this sphere has a radius. Okay, so actually focal point, or this point which is called focal point. Okay, so this focal point in the half distance of the center of curvature. So if this is f, if this distance, which is called from the mirror to the length, from the mirror, okay, to the focal point, this is called focal length. This is called focal length. And actually it's in the midway between the center of curvature, okay, and the mirror. So if this is f, or this distance is called f, so the center of curvature, which means it's the radius. So this is the radius. So if I take this distance now, this is called r, or the radius, which is 2f. So actually, okay, so this concave mirror, it's a part of a sphere, and this sphere has radius. Okay, and this radius equal double the focal length, which means focal length in the midway, okay, or in the half distance, or equal the half distance, or the half value of the radius. So equal r divided by 2. So if the radius of this one, for example, is 10, so the focal length will be 5. Let's see the convex mirror. Convex mirror, okay, so the shiny surface here, it's a curved mirror. The shiny surface here, it's the outer surface. So here the outside, it's exactly like the outside of the spoon. Okay, so the outside of a spherical shell, this is called convex mirror. So this is the reflecting surface. Now reflecting surface. It's opposite from concave. Concave, this surface, okay, the inside surface, this is the reflecting surface. But in convex mirror, the reflecting surface is the outside surface. So this one, and here the image which is formed, okay, it's always virtual, because we only have one case. It's always virtual, smaller image. And if it was virtual, so it's upright. So it's upright image, and it's virtual, which means cannot be displayed or received on a physical surface or a screen. And always a smaller image. Where we can recognize this mirror, okay, it's actually like the mirror in the car. So this is like car mirror. So you always see in the car mirror, okay, the image or the other cars look smaller than it is. Look smaller than it is. The reason for this, because always the image formed in this convex mirror, okay, it's virtual and upright and a smaller image in all the cases. But the situation is different in a concave mirror. In a concave mirror, the situation is different. The image depends on the position of the object. let's see exactly what happens when the guy who just watch himself or see himself in front of the mirror. What happens to his image? First, about the image formed, if the rays of light just comes from very far distance object, like the sun, for example, so it's very far away object from from the mirror, so all the rays are just going to focused on the focal point. So like the sun rays, this mirror had the ability to collect all of these rays and put them in one point, which means, or this point is called focal, it's called focal point. But if the object, this is the object, if the object, as you can see here in this situation, at distance away or at a distance, greater than 2f, greater than the center of curvature. So if the distance of the object is at distance greater than 2f, which means it's far away from the mirror, so in this situation, this will be the image. The image will be inverted. As you can see here, this is the object, this is the image, so the image is inverted. And when the image is inverted, this means, or this is an indicator, that this image, it's real image, so this is real image, so this image is real, and it's a smaller image, but here in this situation, the object at distance, this is the distance of the object, so this is distance of the object equal to f, which means it's at the double distance of the focal length. And in this situation, the object and the image are in the same position, and it's inverted image, so the image here, it's inverted, and it had the same size like the object. So here there is no magnification. Magnification means the object will look smaller or greater than its image. So here the image and the object have the same size. So there is no magnification. So the magnification here, the magnification equal 1. But in this situation, now it's the image or the object, it's at distance, so this is the object at distance greater than f, so he just greater than f, and less than 2f, so distance greater than f and less than 2f, which means it's at point between f and 2f. And in this situation, the object is going to be greater object, so the size increases. It's inverted object, sorry, it's inverted image, so the image, this is the image, and the image is inverted, which means it's virtual, and at the same time, this one, it's inverted virtual, and its magnification greater than 1. Here, as I told you, in convex length, so if this is the object, this will be the image format. As you can see here, all of this image is smaller image and virtual. So this is virtual. So this is virtual image. So let's see again, guys, together what happens. First, in this situation, as you can see here, this guy has a distance less than f. So if it has a distance less than f, so the image in this case, it's upright image, it's a greater image, okay, and it's an upright image, it's a greater image, so the magnification is greater than 1. Okay, once this one, it just move away. So at this situation, it's almost there is no image. If there is no image, this means this guy now stand at a distance equal focal length. So if the focal length is 1 meter for this mirror, now he just stand on the 1 meter away from the mirror, which means it's exactly, okay, at focal point. So at focal point, there is no image is formed, as you can see here. So there is no image, okay. Okay, here still no image. Okay, at this situation, as you can see here, he had distance between F and 2F. So if the distance between F and 2F, okay, if the object is between distance between F and 2F, so the image is a greater image, still the image is a greater, okay, look to his nose, so it's a greater, okay, it's inverted image, so it's a real image. So this image now, it's called, okay, it's real. It's real means upright, it's inverted, okay, and it's a greater image. At this point, the image and the object have the same size, which means this guy now, he stands on a distance equal to F. So if the object at distance to F, the image will be at the same distance to F, which means both have the same size. Still, this is real image, okay, it's inverted, and of course this image can be displayed on a physical surface. Now we can see here he just moving away. So as you can see here, once he just moving away, the image gets smaller, which means, okay, the image in front of concave mirror, its properties and its characteristics depends on how far away you are from the mirror. So if you are very close, the image is different if you are away from far away from the mirror. And this is totally different from a flat mirror, because still in a flat mirror your image is the same at any distance, it still have the same size, it still have the same distance away from the same distance between object and image, okay, so still have the same dimension, but the situation here is different. Also about car's mirror, which is called convex mirror, always the image is smaller at any distance. So if you look to the car's mirror, you will find this image always a smaller image, smaller than its actual object, or smaller than the actual object, and it's upright, which means it's a virtual image. Thank you very much, and this was the end of our session today. I hope you enjoy your time. Thanks.